Welcome to Nano Zorro, the podcast of Tech Zorro, presented by Juditova. Engage with your ears about engineering, development and inventions, as well as interviews with experts and hobbyists. You will learn to make better decisions with your designs, programs and manufactures in order to optimize and develop your products and services, or just for fun. You can find the show notes from the episode, the transcription, and much more by entering to techzorro.com/podcast. And now your host, engineer, crafter, and tech enthusiast, Juditova.
If you like this podcast or the blog, and you do want to support the show, go to our site in Patreon to contribute with a monthly donation. You will have early access to its episodes, you will be recognized as a Patreon in the website, among other benefits. There are several tiers available, starting from $3, or if you feel altruist or generous, there are superior tiers. You just have to go to the website techzorro.com/Patreon. In the show notes or description, you will find the link. We will kindly appreciate all contribution. All right then, let's start with today's episode. Welcome to a new episode, the number 6 to be precise, of Nano Zorro, the podcast about technology, engineering, electronics, programming, networking, etc. Today we are going to talk about regenerative braking, which is a very interesting feature in electric motors. So what is it exactly? Well, let's put it with an example first. It is possible to restore some of the energy that was given to an electric motor. Regenerative braking is a technique to recover partially some current back to an electric grid or a battery while it slows down the motor in the process. In this episode, let's take a look, or in this, to be more precise, let's hear about this technique briefly and what it implies. My undergraduate thesis in the university was actually this topic, and I will love to talk about it. I will leave a link in the show notes of this episode. Before digging into regenerative braking, we have to see one concept before, which is dynamic braking. So before starting, let's start explaining that most electrical machines are characterized by being reversible. They consume electrical energy when they behave as motors, and they deliver it when they behave as generators. Motors are generally composed by a stationary part, which is called the stator, and then the rotating part, which is called the rotor. When the power flows from the stator to the rotor, it will work as a motor. However, when the power flows from the rotor to the stator, then it will work as a generator. So, what is dynamic braking? An electric motor can be stopped if it is disconnected from a power source. On the other hand, it can be stopped more quickly if the motor terminals are reconnected into a circuit of discharge. So all the energy that had inside the motor can be evacuated. However, as the motor slows down, generation decreases, as does this braking efficiency or effectiveness. This means that the motor cannot be safely braked only by this method. This technique is known as dynamic braking, and there are two types: rheostatic braking, and regenerative braking. So, what is rheostatic braking? The electrical energy generated in the motor is dissipated as heat. The motor stator is disconnected from the power supply and connected to a resistor circuit. A part of the mechanical energy of the rotation will be converted into electrical energy, which will be discharged with these resistors. The result will be that the motor will stop sooner than if that energy were not dissipated. And now, what is regenerative braking? The operation of this system consists of returning energy to the battery when it is desired to deaccelerate the vehicle while it is in motion. A vehicle using a regenerative braking system based on an electric motor will be able to regenerate additional electrical energy from the initial charge to extend its distance traveled. In addition, it will consume less electricity when recharging the vehicle and increases the life of friction brakes. This brake works similarly to the braking technique based on the natural compression of a combustion engine. In regenerative braking, unlike rheostatic braking, the electric motor is reconnected during braking as a generator. The power supply terminals become energy suppliers, which conduct electricity to an energy store that can be a battery or capacitors, to a vehicle or back to the mains. This electrical energy is stored for future use. Traditionally, friction-based braking is still used in conjunction with regenerative braking for the following reasons. The effectiveness of regenerative braking is lower at low speeds, and the amount of energy can be recovered is limited to the availability of the power system to absorb it or the state of charge of the batteries or capacitors. For this reason, it is necessary to have a rheostatic or friction brake to absorb the excess of energy. Principles of regenerative braking. Some principles involved in braking an electricity generator in an electric motor are: the magnetic field can be generated by permanent magnets or by electromagnets. In the last case, the magnetic field can be variable. According to Faraday's law, when the winding wires move and cut magnetic field lines, an electromotive force is produced in the conductor. According to Lenz's law, an induced current in the conductor will create a magnetic field that will oppose the magnetic field that produces it. This is the force that stops the electric motor. What are the requirements for regenerative braking? The feature in the electric motor shouldn't just quote-unquote exist. There has to be a mechanism or circuit that takes the energy from the regenerative braking in the terminals of the motor to then transform it to the nominal battery voltage. Although there are cases where no extra hardware is needed, but it depends on the controller, definitely. And that means there is no just one way to do so. In my thesis, I opted to design a circuit capable of doing so. It was built with relays that disconnected the motor from the external controller and then connected to a DC-DC converter and then to the battery. In many cases, no extra hardware was needed in the first place. But since I didn't want to touch or compromise the controllers, I built this different circuit. The quantity of energy available is directly proportional to the size or power rating of the motor. Instead of focusing on such parameter, we should focus instead in the efficiency of the system. As I found out in my thesis, there was a efficiency increase as the regenerative braking was more intense. The more braking that happens, the more efficient it was per meter traveled. In a test with higher differential energy potential available, the efficiency rose up to 13%. On the other hand, when braking in a plane with lower differential energy potential, the efficiency was lower, up to 7% or even lower. Research on this topic indicates that energy savings are indeed achievable with a recovery of 8 to 25% on the vehicle's total energy use, depending on the state of charge and its control strategy. This additional energy recycle can be achieved without adding additional components, as this research suggests. I will link in the show notes below. Due to the importance of this technology, many researchers have conducted such investigation. The safety and driving comfort of vehicles are strongly related to braking performance due to various phenomena associated with pedal and brake operations. In regenerative braking system, or RBS, the objectives of safety, reliability, and easy application are the main factors to be considered. Now, there is also an important question to be asked. Is regenerative braking available in engines from fossil fuels? Electric vehicles have a lower energy storage capacity than fuel tanks, until now, of course. Currently, energy density is low and energy consumption must be optimized. Regenerative braking is a solution to extend the autonomy of a battery because braking could generate a torque generator. This is one of the most important advantages of electric motors over combustion engines, which are not reversible. Even worse, braking using a fossil fuel engine increases the consumption of energy since revolutions per minute increases. Ooh, too bad. That's all for this episode about regenerative braking. Did you know that this feature existed? What do you think that is going to be the future for electric vehicles, such as cars, motorcycles, bicycles, with the incorporation of this feature? I mean, there is already available in the motors, but if these vehicles can achieve or really use this feature, could exploit this feature, I want to mean, I will leave the link of the blog post in TechZorro in the show notes or description of this episode, so you can comment or see the comments of other people. Well, that's all, folks. See you in the next episode. I hope you have enjoyed this episode so far and that you have learned something useful for your next craft or project. Before you go, I just need a favor from you. Go to the application where you are hearing this right now and leave us your honest review and a like or a rating from 1 to 5 stars. This way, more people will be able to find this episode and enjoy it as well. It will mean so much. Juditova says goodbye. Until next time.
That's all for this episode. We hope that you found a moment of enlightenment and that you have enhanced your skills or cleared some doubts. For more interviews, tutorials, blueprints, and advice, go to the website techzorro.com/podcast. Juditova expects you in the next episode. Don't forget to subscribe. Happy crafting!